This is Bob Capetta, and this lesson is on quadratic functions. We're going to start with the function f of x is 2 times quantity x minus 3 squared minus 5. So what does that look like? How is that behaving? What is its shape? How is it shifted? The foundation of this is the function f of x equals x squared, or y equals x squared. And it's moved around. It's shifted and it's stretched. So here's our general form. F of x is a times x minus h squared plus k. Now what can we say about this? How does this compare to the function x squared? Well, x minus h squared takes the function x squared and shifts it h places to the right. The plus k shifts it k units up, and a is a stretch factor. So shifting it h to the right and k up gives us our vertex. The vertex is going to be h comma k based on the transformation. And the a, the 2, is going to double our graph of x squared. That gives us the shape. So I say the shape of the function in general is y equals ax squared. So in this case, what's our vertex? What's our shape? Shifted over 3, shifted down 5, our vertex will be 3, 5, negative 5, over 3 down 5. And our shape is going to be y equals 2x squared. And that's going to be enough for us to graph the function. Again, x minus h is a shift h to the right. X minus h squared is a shift of x squared, h to the right, hence the vertex is h. Plus k shifted k up, a is a stretch factor. So there's our vertex, there's our shape. I want to create a table of values for y equals 2x squared. So like if x is 0, y is 0. If x is 1, 2 times 1 squared is 2. If x is negative 1 squared is 1 times 2 is 2, etc. This will give us the shape that we need for our quadratic function. So starting with the vertex is at 3, negative 5, as we have on the graph here. Over 1, up 2. So from this point, over 1, up 2, negative 1, 2, back 1 on the x, up 2. So I have these 2 points that are at the y values of negative 3 that are 1 unit away in the x direction. So in this case, 2, negative 3, and in this case, 4, negative 3. Now we have 2, 8. Over 2, up 8. So up 5 and up 3 more. Over 2, up 8, up 5, and up 3 more. So if we graph all of those points, I have 5 points, and I will connect them. And here is the graph of that function. So if we're given something in the form a times x minus h squared plus k, we get the vertex, we get the shape, we make a table for the shape, we can construct a graph. But there are some things we can answer about this function. Namely, the leading coefficient is positive. The 2 is positive, so the graph is going to have a minimum. It's going to look like a U. The lowest point is at the vertex. So we can recognize here that this function achieves the minimum value, lowest possible value ever of negative 5. Where does that occur? When x equals 3. Now, we want to think about where is it decreasing and where is it increasing. So the metaphor is a roller coaster, from left to right. Here the roller coaster is going down. Here the roller coaster is going up. So we say the function is decreasing on the interval from negative infinity all the way down to 3, x is 3. Increasing on the interval from 3 to infinity. And what else do we know? The axis of symmetry. This acts as a mirror. Through the vertex, vertical line through the vertex, x equals 3 is the mirror. So a point on this side has a mirror image on the other. A point on this side has a mirror image on the other. So we can define the axis of symmetry by looking at the graph. Now, what about the y-intercept? Where does this graph intersect the y-axis? Where does it hit the y-axis? I can't tell. I didn't draw this large enough to see where it hits the y-axis. Somewhere above 6. But the answer to that question is f of 0. So when x is 0, what is the y value? Well, if I plug 0 in, what do I get? 0 minus 3, negative 3, square at 9, times 2 is 18, minus 5 is 13. So when x is 0, y is 13. That will be my y-intercept. That's where the graph should cross the y-axis, does it? It sure does. We see from our picture here, the graph crosses it at 0, 13. What about the x-intercepts? Where does it cross the x-axis? I have an x-intercept here and an x-intercept here. For quadratic functions, I could have two x-intercepts. I could have none. For quadratic functions, you'll always have exactly one y-intercept. If you had two, it wouldn't be a function. You would fail the vertical line test. And 0 should be in the domain of any quadratic function. So you'll always have exactly one y-intercept. But in this case, we have two x-intercepts. We've got to set f of x equal to 0 and then solve for x. So 0 equals 2 times x minus 3 squared minus 5. Now, my guess is many people may want to solve this by expanding all this, multiplying it out, simplifying it, and then using the quadratic formula. That is not the most efficient strategy. I'm going to use the square root property instead. Isolate the x minus 3 squared, so add 5 to both sides and divide by 2. Next, I want to take the square root on both sides, but you have to remember, if you take a square root, you've got to put in a plus or minus. So x minus 3 is plus or minus the square root of 5/2, just switching left and right to make it a little easier to see. Then we'll add 3 to the other side, so x is 3 plus or minus the square root of 5/2. So one of those numbers, 3 plus root 5/2 is here, 3 minus root 5/2 is here. But that's not going to be a pleasant enough answer. We're going to go ahead and rewrite that using prettier numbers by rationalizing the denominator. Root 5/2 is root 5 over root 2. Multiply top by root 2, multiply bottom by root 2. Root 5 times root 2 is root 10. Root 2 times root 2 is 2. So we get 3 plus or minus root 10 over 2. I'd like a common denominator. 3 is 6 divided by 2. So 6 over 2 plus or minus root 10 over 2, which I then can write in the form you're used to seeing from the quadratic formula. 6 plus or minus root 10 over 2. So this number on the right should be 6 plus root 10 over 2. The number on the left should be 6 minus root 10 over 2. Let's see if that's the case. What is 6 plus root 10 over 2? It's about 4.581. Well, you see it's crisscrossing between 4 and 5, pretty close to halfway, so maybe 4.581 seems reasonable. How about 6 minus root 10 over 2? You see it's between 1 and 2. What do we get? About 1.419. Again, pretty good. We're going to check on Desmos to see what Desmos tells us. Indeed, 4.581 and 1.419 are going to be my x-intercepts. Values on the graph where the y is 0. That is my collection of x-intercepts. But what made this reasonable was it was given in this form. Transformation shifted 3 to the right, shifted 5 down with a shape of 2. But in general, we don't have that. So if I have a situation like this, f of x is ax squared plus bx plus c, how do we do this analysis? What do we do? For this problem, I want to focus on the vertex. How do I find the vertex? So here's an example. F of x is 3x squared minus 5x plus 2. The vertex is down here, the x value between 1/2 and 1, the y value just a little bit negative. We want to find that vertex, and I'm going to give you a nice technique to get there. What is that technique? Well, here's our general form, ax squared plus bx plus c. A in our case here is 3, b is negative 5, and c is 2. The vertex occurs when the x value is negative b divided by 2a. That's this x value between 1/2 and 1. The y value, plug that negative b over 2a into the function to find the y value. So we know a, we know b, we know c. We want to find negative b over 2a, the negative of negative 5 over 2 times 3. That will give us the x value of our vertex. Negative b over 2a, negative of negative 5 over 2 times 3, negative of negative 5, 5, 2 times 3 is 6. So 5, 6, that seems reasonable looking at our graph. 5, 6 is here. But what is the y value? To find the y value, I've got to plug 5 6 into my original function, which was 3x squared minus 5x plus 2. We'll plug 5 sixths into that. So f of negative b over 2a is f of 5 6 3 times 5 6 squared minus 5 times 5 6 plus 2. 5 6 squared is 25 36ths. And probably a job for a calculator to help you with the computation. 3 times 25 36 minus 25 6 plus 2 is negative 1/12. And that seems about right. X value 5 6, y value negative 1/12. So let's put that label on the graph. The vertex is there, and there's our appropriate graph. Now let's think about some other things here. What can we talk about? We know the vertex. Decreasing, the roller coaster is heading down, negative infinity, and it turns around at 5 6, so it's decreasing from negative infinity to 5 6, but then it's increasing from 5 6 to infinity. And we know what happens here at 5 6. It achieves a minimum value. What is the lowest value it ever achieves? Lowest value it ever achieves is negative 1/12. So we can say f achieves a minimum value of negative 1/12 at x equals 5 6. Also, the axis of symmetry, if you wanted the mirror, would be at x equals 5 6. You would have points on either side that would mirror each other. So remember, this was a parabola whose leading coefficient was positive. Okay, that's why it was opening upwards. What did we start with? We started with 3x squared minus 5x plus 2. The 3 is positive, that's why it's opening upwards. If I start with one that's negative, it'll be opening downwards. So here's my example, negative 2x squared plus 6x minus 1. So that should look different. In this case, a is negative 2, b is 6, c is negative 1. Again, I'm interested in the vertex. Negative b over 2a is the x value. Negative b, negative 6 over 2a. Over 2 times negative 2. Negative 6 over 2 times negative 2. Negative 6 over negative 4 reduces to 3/2. So the x value is 3/2. What is the y value? I've got to plug 3/2 in for x to see what the y value is. So that's negative 2 times 3/2 squared plus 6 times 3/2 minus 1. Again, maybe a job for a calculator, and we get 7/2. So the x value is 3/2, the y value is 7/2. That is our vertex. But remember, it's opening downwards. So this is our picture. And what can we say about this? There's our vertex. This time, the roller coaster is increasing first. Roller coaster is increasing from negative infinity to 3/2. And it's decreasing from 3/2 to infinity. And in this case, the function achieves a maximum value, highest possible value of what? Of 7/2 when the x value is equal to 3/2. Now, what about the intercepts? Can you think about the y-intercept here? Where does it cross the y-axis? Crosses the y-axis here, and where does that occur? That occurs when the x value is 0. If the x value is 0, negative 2 times 0 squared plus 6 times 0 minus 1 lands me at negative 1. So indeed, plugging 0 into the function, we get negative 1, and you can see the y-intercept is here at what point? At the point 0, negative 1. Now, what about the x-intercepts? What do I do to find the x-intercepts? I've got to take this function and set it equal to 0. So we must say 0 equals negative 2x squared plus 6x minus 1. Or if you prefer, negative 2x squared plus 6x minus 1 equals 0. Just switching left and right side. This will be a challenge, and the tool I'm going to choose to use is the quadratic formula. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. B is 6, A is -2, C is -1. So you'll see -6 plus or minus 6 squared minus 4A, 4 times -2 times C times -1 over 2 times -2. 6 squared is 36. -4 times -2, positive 8, times -1 is -8, so 36 minus 8. 36 minus 8 is 28, so we get -6 plus or minus 28. 28 is 4 times 7, root 4 is 2. So root 28 is 2 root 7. And then I'm going to break this up into two pieces. -6 over -4 plus or minus 2 root 7 over -4. -6 over -4 is 3/2. 2 over -4 is 1 over -2 or -1 over 2. So when that happens, we usually just take plus or minus and change it to minus or plus by reducing that fraction. So you have 3/2 minus or plus root 7 over 2. So 3/2 minus root 7 over 2 or 3/2 plus root 7 over 2. And what are the decimal approximations for that? We have about 0.177 and about 2.823. So we want to look at a graph to see if those x-intercepts are what we get, and we ask Desmos, and what does it give us? Indeed, one of the x-intercepts at 0.177 and the other at 2.823. And that will conclude this lesson.